Please don't embarrass me in the middle of my class. Okay, 15. Where are you, 15? What is it? Okay, so we have -3 comma -3. Perfect. Perfect pick. Okay. On the coordinate system, -3, -3. Here's the point. Here's the terminal side. Here's the angle theta. Here's the reference angle. Here is the right triangle. This is 3 units. This is 3 units. I need to determine the hypotenuse. So,
Professor, can
yes.
you change the
yes,
screen?
I'm sorry. Let me start again. So, -3, -3, -3 for x, -3 for y. So this is the point. And this is the angle in standard position. Beginning, or initial side, I should say better, and the terminal side. And this in here is the acute angle, which is the reference angle. This angle does not fit in a right triangle, but this one does. And this one, this angle will give us sine, cosine, tangent, cotangent, secant, cosecant for theta. Notice that in the third quadrant, both sine and cosine are negative. So make sure that you get sine and cosine to be negative numbers. Of course, when you determine tangent and cotangent, it will be positive. But when you determine secant and cosecant, it will be negative because they are 1 over these. And I wanted to just go one more time here just to make sure that we got, so secant, so this was the fourth quadrant. Yes, the secant is okay, cotangent is negative, tangent is negative, and cosecant, yeah, it was okay. Perfect. Just making sure. Good. So I need to determine this piece. But this is a right triangle with 3, 3, and unknown. 3 squared is 9, plus 9 is 18. The unknown is the square root of 18, and I have to simplify it. It's 9 times 2. So I have to write 3, the square root of 2. So this piece is 3, the square root of 2. Knowing all these, I'm done. I just have to write them out. But the whole thing is done. If I can separate these pages, I will be able to write. Okay, good. So I have sine theta. It has to be negative because the terminal side is in the third quadrant. So the reference angle, opposite over the hypotenuse. 3 divided by 3, the square root of 2, is 1 over the square root of 2, or the square root of 2 over 2. And I said it's negative, and I didn't write it. I said it twice, or 3 times. Okay? Next. Cosine theta. It has to be negative. But it's going to be the same thing. They're the same. Because adjacent over the hypotenuse or opposite over the hypotenuse, since these two are the same, this has to be the same. What about the rest? I don't care for the table or chart or anything. I care get tangent, 1. Cotangent, 1. Secant, they have to be negative. If cosine is negative, secant has to be negative. Flip, -2 over the square root of 2, or -2 the square root of 2 over 2 simplified into the square root of -2. Negative the square root of 2, I meant to say. And finally, cosecant theta, exactly the same. As expected, only tangent and cotangent will be positive because sine and cosine are negative. 1 over those, 1 over cosine has to be negative. 1 over sine has to be negative. And it's done. You only need to determine sine and cosine. Any questions? Do we feel a little bit better about the first set?
Yes.
Okay, I'm not trying to skip this. I'll come back to it. Name the quadrant in which the angle theta lies. So I'll choose one, and please choose the second one afterwards. Okay, so let's say, I don't know, 35. They're telling us sine theta is negative, tangent theta is negative. Okay, so they're telling us that there exists an angle theta whose sine is negative and tangent is negative. Piece of cake. Sine is negative. Oh, okay. Tangent is negative. Oh, okay. Which of all four quadrants fulfills both conditions? Sine negative and tangent negative.
Quadrant 4.
That's it. Absolutely. Okay, let's choose another and then come back to the previous set. Anyone would like to choose another?
$37.
You said 37. Perfect. In 37, we have cosine theta, they say, is positive. Cotangent theta is negative. Perfect. Draw the circle. Cosine is positive. Cotangent is negative, because cotangent is positive here. Both sine and cosine are positive. Cotangent and tangent are positive. Both cosine and sine are negative. Tangent and cotangent must be positive. So this is when tangent and cotangent are negative. Which quadrant fulfills both conditions?
Fourth.
Again, the fourth. Okay, let's take a look at the other set that we just went over. Use a coterminal angle to find the exact value of each expression. I need to explain what a coterminal angle is. Okay. Two angles are coterminal if, so two coterminal angles have same initial and terminal sides. Okay. For example, this angle, I'm going to call it alpha. And this angle, I'm going to call it beta, are coterminal angles. One is positive, one is negative, but they both start at the same point, the same initial side, yes, and same terminal side. There are infinitely many coterminal angles with alpha. Here's another one. One, two complete rotations and plus alpha. So I'm going to call this angle gamma. So gamma and alpha are coterminal angles, both positive angles. Gamma starts at the same initial sides, has the same initial side, and has the same terminal side with alpha. they are coterminal angles. So alpha and beta are coterminal angles. Gamma and alpha are coterminal angles. Gamma and beta are coterminal angles. All of them are coterminal angles. Yes, alpha and gamma positive angle, but beta negative. So now we are ready to choose. Sorry. Use a coterminal angle to find the exact value of each expression. Do not use a calculator. So we have problems 21 through 32. Which one would you like to look at?
We do 24.
You said 24?
Yes.
390. Perfect, perfect, perfect. So that's 24. We want to find sine of 390. Okay. First of all, I have to picture what this is. And I know that a complete rotation is 360 degrees. So this is 30 degrees more. So I want to picture this angle. It starts here. It goes around the circle once for 360, and then 30 more. So here is the reference angle. Can anyone tell us how much is sine of 390? And you have to say it's exactly the same with sine 30. So this is the 390 degrees, and this is 30. Sine of the big angle is the sine of the reference angle. How come? Because the reference angle is in the first quadrant. It may be here negative sine 30 if it ends in the third quadrant. And it may be here also negative, but it ends in the first quadrant, so this sine 30 degrees. What is sine 30 degrees? The easiest number.
1.5.
Exactly, thank you very much. Half. Good. We're basically using the reference angle in this case. Let's choose another. Let's look at tangent, number 31. That caught my eye. Okay, number 31. Tangent 21 pi. And which page am I on? 12. Okay. So let's take a look at this. I have no idea what 21 pi is. But I know that 21 pi is 2 pi times 10, so 10 full rotations, plus another pi, 21. 2 times 10, so this is basically 20 pi plus 1 pi. That is 21 pi. So the 20 pi is basically 10 full rotations. I don't care for it. What does that mean? I don't care. Because I start here and I go around the circle 10 times. But then I have plus pi. So the angle starts here and it ends here. Yes, and 20 times, 10 times around the circle. But still starts here and ends here. So this is the full angle, the 21 pi. That's the terminal side. So I have to use, and you can say, but what is the reference angle here? Okay. As long as we have one of these points, we don't need the reference angle. because there is no acute angle. Or if you want, you can say it's 0, but I cannot even picture that, right? So all I have to do is identify the coordinates of this point. Does anyone remember what the coordinates of this point are? We know this from beginning algebra.
-1, 0.
Very good. So it's asking us for tangent. So tangent 21 pi equals tangent pi. But tangent pi is sine over cosine. Sine over cosine. 0 over -1. How much is that?
Zero.
Excellent. That's it. Because it's sine over cosine, and cosine is -1. Careful how you use the graphing calculators I mentioned. Where's my calculator? Here. So if you want to make sure that your mode is in radian mode, and we go to tangent 21 pi, and if we don't get 0, I have to start from scratch. That's a very good point. This is 0. The calculator and the software, they have errors. But if I write tangent of pi, it should give us 0. So careful with this. I did not anticipate, I did not expect that the calculator will not be able to handle 21 pi. And it's not really able to, but you know what this means, right? So 2 times 10 to -13 means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. This is the error of the calculator. The calculator is really telling us 0. 2 times 10 to -13 means 13 digits after the decimal point. Any questions? So careful with this. Of course, you would not copy this, right? Okay. So I just want you to work on one problem. Let's say 34. And that's for you. Identify the quadrants. Sine is negative and cosine is positive. We did not finish by any means 5.3. Please start working